Hi, I'm John.
And I'm Lou, and this is
A hot take.
steaming.
So, this is part three in an ongoing series where we talk about the future of convergence of several key technologies. And if you haven't been following us up to this point, I highly recommend going back to the first episode where we talked about the convergence of AGI, superintelligence, quantum computing, and potentially uh, low cost and ubiquitous energy in the form of potentially as nuclear fusion. All of these hitting in the year 2035. And if you're on YouTube, I'll put a link right above Lou's head so you can get to that easily. But I think it makes sense to watch those in order so that you can catch up. If you are caught up, let's go ahead and move on. So what we've done is we've taken that scenario, we've fed the criteria into ChatGPT, and we've asked it to give us the future in 2045 and 2055. So 10 years after that convergence and then 20 years after that convergence. And what do various industries look like? We're starting with enterprise IT because that's our world, but we will go into medical, manufacturing, education, and others. We will also do episodes on dealing with the ramifications of those or the roadblocks that might stop us from getting there. And that'll be a whole separate set of episodes.
So,
In episode 2, I did talk about like all the criteria and constraints that I gave to ChatGPT, so I'm not going to go through all of that now. But what we're going to do is talk about what enterprise IT looks like in the year 2055.
I am going to add one constraint that I think is going to start biting.
Sure.
It's not in ChatGPT, and the good news is that our view of the future takes this into account. But by 2055, the drop in population should start to be an issue.
Correct.
The drop in population in China, the leveling out of population in Africa, which is just pretty much currently happening. But everybody is going to be concentrating on the fact that they are suddenly confronted by the fact they don't have enough people. So with that in mind, a lot of this makes a lot of sense. Why don't you kick us off here?
Sure. So we put these in order of like building blocks. So one builds upon the next to make sense. So the first one is the neural interface as your primary input. So in 2045, we talked about basic neural interfaces, something that would be either glasses and an earbud or a dot that you would wear that would get the basic ideas of what you're trying to get across. Now we're talking about non-invasive, high-resolution neural links, effectively reading your mind so the computer knows what you want and has full intent-based communication with you. So this is effectively rendering voice and typing completely obsolete. You might go to those as a fallback if there's an environment where it's not working for some reason, but I'm expecting that most people will not actually know how to type on a keyboard. They would do most of their computing through this type of interface.
And another thing we should point out is that at this point, you will probably have additional stuff like gloves that you wear that give you haptic feedback. And this has already been experimented with, and I can get a lot of the hand motions with cameras and other stuff, but you will be able to virtually feel surfaces. This will be sort of as an add-on in 2035, 2045, 2055, it's standard.
So, Lou, I would say that that's a possibility. It could also be that neural interface might actually provide some of that in a bi-directional way. So
that would be really good
too. So it'd be, again, when it gets to this point of granularity of understanding the exact form factors, that's going to get really hard to predict because as things change and so forth. So again, 40 years ago, you would not have predicted that the smartphone would look the way it does today, and that that we would have self-driving electric cars, but not flying cars. So we're going to be kind of careful on the exact form factors, just a general technology.
This is actually pretty conservative.
Yes,
when you get down to it. So when you talk about these interfaces, you're talking about really advanced, like real spaces.
Yeah, three things come together here. One is unified AGI workspaces, holographic and neural collaboration spaces, and governed digital AI assistants. So what that means is that you have an environment that's customizable to you, that looks like a holographic environment. Basically, what we're talking about is effectively Jarvis and that 3D interface from Iron Man. Now, the way that that manifests itself would probably be different than what we've seen in Iron Man, but that's effectively what it is. You have a system that understands your intent. You give it the the notions of your ideas, and you do the actual real human thinking and the creative work, and then it does all the mundane stuff for you, and it displays it in a 3D environment. Now, the question is how does that holographic projection happen? And Lou and I were discussing that, and the problems with holograms are the medium in which they're projected. So you either need some sort of mirror system, or you need smoke or some other mist kind of system, and that doesn't seem like it'd be realistic. However, if you have lenses, contact lenses, glasses, or something else that we haven't considered, maybe something that's actually projecting into your eyes, then that holographic projection becomes virtual and you see it, but maybe somebody else wouldn't, unless they're in the same collaborative space that you are.
But the reality is coordinated by incredibly ultra low latency communication and incredible computing power.
Correct. So building on what we talked about from 2045, all those things building up, now you have, again, effectively unlimited, almost free power. You have effectively unlimited compute capabilities, and you have these like constantly evolving super intelligence. All of those things coming together, this is going to come much quicker than we think. And I was thinking about it. I was talking to my son this morning. 2055, he's still going to be in the workforce. So this is something that is real for people that we know. This timeline is something for people that we know. So whether we'll still be in the workforce or still around at that time, maybe or maybe not. But Gen Zs and Gen Alphas will definitely be around in that time frame.
Think Snow Crash.
Exactly.
Right. If you've read Neil Stephenson's Snow Crash, I think that is the level of interfaces we're going to have in 2055.
But
if not
probably in a more elegant way, where you don't need the big bulky headsets and such. I think.
Well, basically, yeah, that was. There's going to be levels that people are going to get to. The new religion may be, how connected am I, right? And you know,
we'll talk about some of those in our constraints and issues and roadblocks as well, because there are going to be some things around that. But let's move on to number 3, and those are two different pieces that come together, which is code as thought and self-composing infrastructure. So basically, this is intent-based computing at its final form. So this is, instead of having to write code to accomplish tasks, this is thinking about what you want done and having the computer figure out how to accomplish that on its own. And then it writes the code, or whatever, it does the tasks that it needs to perform, and then presents it to you. This is a series of apps and microservices and APIs that are all talking to each other, and all you know to do is to think about something, and then you'll get that, whether that is planning out an itinerary, things that you could do today with AI, but just think of it as more at the speed of thought, and then going a next step further. I'm doing research on, let's go to medical. So we're doing cancer research, and you can start thinking about the different pieces that you want. It'll start going out and gathering the right data, correlating them in the right way, and you have an idea that maybe these pieces could fit together in one way or another. It would run models for you based on that and give you a projection.
What if I change this protein shape? What if I attach to this piece of DNA? It will model it for you in real time. If I'm building an airplane, I'm literally holding that airplane in front of me.
Correct.
Virtually,
now,
and going.
Where this goes, and the natural question is, well, if we don't code anymore, who's building the next generation of hardware and architectures and so forth, so that we can continue to evolve technology? And the answer to that is humans with super AI and AGI doing that. So the AGI would be taking care of the shrinking of the dies and the transistors on the device, and the mapping them into more efficient ways, and actually the actual underlying assembly code that most humans wouldn't have to know, and providing an interface, and maybe even optimizing that assembly code in ways that we wouldn't have to think about. Now, to some degree, that can sound a little bit scary, but there would still be humans that are supervising the hardware architecture. You would still need people that understand that architecture, but what you don't need is a million people that understand C++ or assembly language or something like that.
Think about it this way. See this thing? This is a USB dongle for plugging in memory devices. Do you know how this works? Do you, my watcher, know how this thing works? Okay, I do. I have an electrical engineering degree. I've studied some of the bus protocols in this. You probably don't. And the reason you don't doesn't make me superior to you. It means you don't care.
Right.
For the most part, I don't care. As long as I plug memory into this and I plug it into a port and it works, you can't tell me how the radios in your cell phone work. You don't know about the miracle of switch capacitance and how much that's changed everything in control theory. You don't have to know. And that's the key piece. There will be people who know. There will be people who continue to do this. There will still be people studying physics. There will still be engineers. What form that engineering will take is sort of up in the air. Electrical, a lot of it's going to combine. It's broken out because it's gotten so complicated. Now what we're going to see is a combination of it again due to intent, right?
And a whole new realm of employment opportunities will open up because of these technologies. So the fact that there will be less coders doesn't mean that people will be out of work. It'll mean that there are other opportunities out there. Just like 20 years ago, maybe a little more than that at this point, there was no such thing as a cloud engineer. There was, 50 years ago, there was no such thing as a GUI designer, with the exception of a few people working at Xerox PARC or someplace like that. And we'll see the same type of thing. We'll see as these technologies start to become a little more self-running. How many people learn assembly code today versus in the 80s? I mean, most code in the 80s was written in assembly code. Now it's not. So that's the kind of thing that we're talking about. You don't have to understand the lower layers. You just understand the top layer. In this case, that's that thought-based intent.
But as you'll remember from the early days of the web, when all of us got out there and started creating stuff, not everything was created equal and not everything was of value. And all of us have our own personal websites out there still trying to figure out what to do with them. There's going to need to be people who think in terms of systems. Systems
Correct.
thinking isn't going to go away. So, John, can I run through this list of people you have?
Sure.
Like intention engineers. Who defines the goals, the edge cases, and the ethical boundaries for what you're doing? Digital ethicists, experts in AI alignment, fairness, and unintended consequences. Good Lord, we drown in those, right? Maybe we need to start looking ahead and seeing what happened. System curators, right? Who oversee AGI behavior, handle exceptions, guide innovation strategy. You're probably going to want somebody to guide the creation of your helper, right? Because basically, we're looking at the invisible friend that stays with you for your entire life. You're going to want some guardrails there. Cognitive architects design human AI collaboration workflow and interface protocols. These are all things we're going to need. We didn't even talk about genetic counselors 30 years ago.
Right.
Now we have them. Yep. So think about, this is once again extremely strategic. Do humans still learn low-level concepts? Yes, but only in niche areas. So, John, I'm going to say that the basic like calculus, the language of engineering, you're still going to learn that. You're going to get a better understanding of it. Linear algebra, basic physics concepts like vectors and material strength, stuff like that. That's still what everybody goes through to be a maker. From the atomic level, they're still going to do. It's just going to be much easier, and there's going to be less reason to focus narrowly.
Absolutely. That is going to cover this episode. Do you like the direction we're going with these hot takes, where we're looking at the future? Would you rather us stick closer to today and keep on top of the IT news, which we do every Monday now anyway, but do you want us to just stick more towards that? Because we couldn't do this podcast without listeners like you, and we want to hear what you think. Do you have different topics that you want us to cover? Send email to feedback@itsparkcast.com or hit us up on X @itsparkcast. If you're watching us on YouTube, you can leave a comment down below. We read every comment and every piece of feedback that we get. We respond to most, and if it's particularly insightful or entertaining, we'll read it out on our broadcast. Make sure you hit like, subscribe, and turn on notifications. That way you never miss an episode. And so with that, from the world of enterprise IT and the future, take care.
Remember, if you don't like our future vision, let's build a better one.